And we're recording. Okay, so today is Tuesday, February 16th, and we are all at home learning digitally. So let's get started. Our question got covered up. So take a look at the model shown, and what fractions do you see? So notice how many parts of the whole are purple, how many are blue, and how many are red. Think about what your numerator is going to be, what your denominator is going to be. Let me write in white so it'll show up a little bit better. Actually, let me do this. All right, what fraction of our shape is purple? Purple. We're going to do all the colors, purple, blue, and red. So the first thing that we need to do is count how many parts our whole rectangle has been cut into, which is a lot. So that number is going to be our denominator, our downstairs denominator, the number that's going to be on the bottom of all of our fraction bars. So how many boxes do we count in total? Uh-oh, I hear somebody trying to unmute, but I didn't hear an answer. All right, how many boxes do we have in all, guys? Somebody needs to volunteer.
Which one?
Javier, how many boxes do we have in total? How many parts?
18.
18, let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so Javier was correct. We have 18 total boxes that our whole rectangle has been cut into. So how many of those boxes are purple? How many of those boxes are purple? What part of it is purple? What'd you say, Aisha?
9.
9. Fabulous. Okay, so we know that the part that will be blue and red will also have a denominator of 18 because the number of boxes has not changed. How many parts are blue? How many parts are blue?
3.
3. Thank you, Natalie. And how many parts are red? Guadalupe. 6. Fabulous. So we are going to be moving on to the next thing. All right, our learning target for today is that we can start to recognize and generate, which also means to create equivalent fractions. So we can draw models to show 2 fractions that are equivalent, okay? So I do, you watch. Kevin's bookshelf has 3 shelves. Only one of the shelves has books. Kevin says that 1/3 of the shelves has books. His mom says 2/6 of the shelves have books. Are they both correct? So I'm going to draw a model to show my thinking. Oops. I'm going to draw a model to show my thinking. And we're going to be sketching, oh, that's white. Y'all can't see that. We're going to be sketching square models today. So I know that his bookshelf has 3 shelves. So the whole bookshelf needs to be partitioned into 3 equal shelves. There's the top shelf, the middle shelf, and the bottom shelf. Next, it says only one of the shelves has books. So I'm going to shade one part because only one part of the shelf has books in it. Okay, so his mom says that 2/6 of the shelves have books. Are they both correct? So right now, what fraction am I seeing? I am seeing a fraction with a numerator of 1 because one part is shaded pink. And the denominator is going to be 3 because I know my whole has been partitioned into 3 equal pieces. Now, I'm going to take a look at the fraction that his mom talked about, 2/6, and I'm going to write that down. So we're trying to see if 1/3 is equivalent to 2/6. So again, I'm going to take a look at my denominator first. And I'm going to use the same model that I started with, okay? So the denominator is what in the fraction that the mom said? What's that denominator? The denominator is 6. So I need to look at this model and figure out how I can get it to be partitioned into 6 equal pieces. Well, right now I see 3. So let's see if I add a line this way. 1, 2, 3, 4 pieces, and those don't look equal. 4. 1, 2, 3, 4. 5 pieces, they're still not equal. So I'm going to add another line up here. Notice how I've added a red line in each part of my model. So once I've added my red lines, now I notice that 1, 2, 3, 4, 5, 6, there are 6 total pieces. So that's good. Are 2 of the pieces now shaded? Whoops, sorry guys. Are 2 of the pieces now shaded? Put your thumb up if you think yes. Put your thumb down if you think no. Yes or no? Do you think there are 2 out of the 6 pieces are shaded? Pink. Yes. Okay, so let me check in the... All right, show me with your thumb. Yes, you agree with mom? Or thumb down, no, you disagree with her. Yes or no? Axel, thank you. Sweet Lolly, thank you. Genesis, Aiden, Guadalupe, Natalie, thank you for showing me your answer with your thumb. Mia, fabulous. Brandon, fabulous. So mom is correct. Oftentimes moms are always right. So mom is correct that we can say either the bookshelf has 2/6 of the shelf covered with books, or we can agree with Kevin and say that only 1 out of the 3 shelves are covered in books. Okay. So that those 2 fractions we would say are equivalent, they're equal. Okay, so this is your problem now. You guys are going to work through this one, and I'm going to help you through it. So Luis and Lena are reading Dog Man books. Luis has read 3/6 of his book. Lena has read 5/8 of her book. Did they read the same fraction of the book? Draw a model and explain your answer. So I actually used the same model to be able to compare my 2 fractions. I want you guys to draw 2 different squares to be able to compare. So let me get my black marker out. So you're going to draw 2 squares that are the exact same size to be able to compare your 2 fractions. So go ahead and draw those 2 squares. And one of them is going to show 5/8 shaded. And the other one is going to show 3/6 shaded. So go ahead and work that out. I want you to model 3/6 and 5/8 and tell me if those 2 fractions are equivalent or not. So I'm going to give you just a moment to do this. Give you a little bit of time. And when I'm drawing models to compare two fractions, I should have done this originally, but I like to sometimes draw only vertical lines or only horizontal lines. I'm going to go ahead and start partitioning my square. If you are behind, then you can check my model. To see if you're correct. Make sure that you are trying to get equal pieces. We did a lot of practicing with that. So notice how I did all of my lines horizontally. I'm going to do the same thing for the other model when I'm comparing. So 3/6, I see the denominator of 6 going to partition into 6 equal pieces. 6 are a little bit more difficult to do. Ooh, my lines are not too straight, you guys. The more straight you get your lines, the better and easier it will be to compare. So now what's left to do is to shade how much of the part the fraction is asking us to shade. So I noticed that our numerator is 5. So this means 5 pieces need to be shaded. 1, 2, 3, 4, 5. Now I'm going to shade my other model. I noticed that the numerator is 3, so I need to go in and shade 3 pieces. 1, 2, and 3. Okay, so your models might look just a little bit different than mine. You may have done all vertical lines, and that's okay because we can use that strategy to compare as well. You'll eventually figure out a method that works for you. But I do like to practice all of them because I feel like that makes me a better mathematician. So I need to now compare 5/8 and 3/6. So I noticed that the very middle of the model for both of them is right here. When I cut them in half, those lines matched up right here in the middle. So what do you guys notice about the two models that I drew? Can someone compare the area of 5/8 to the area of 3/6? Can somebody tell me which one is bigger or smaller, or maybe if they're equivalent? Let's see, does anybody have their hand up right now? I think you guys are still maybe working on it. Put your thumb up if you're still working on your own example. Okay, Javiana's still working. Axel's still working. Okay, I'll give you just another minute and then we'll talk about the answer. While you guys are finishing up, I'll go ahead and do this same problem with two models with vertical lines. Okay, so maybe you tried to do it like this. Oop, that is not a straight line. Let's see here. Okay, I'm almost done, so make sure that you are done in just a moment as well, because we have to move on. And I would be doing a much better job shading if I had my mouse at my house, but I do not. Okay, so who drew their model with horizontal lines, like over here? Who drew their model with horizontal lines? Aisha did, okay. Did anybody like to do it with vertical lines like we have on the right-hand side over here? No? Okay. So either way will work. We could also do vertical lines and horizontal lines. I'm not going to model that for you. I can do that for you tomorrow when we come back to school. But what did you guys notice? Were these two fractions equivalent? Yes or no? Yes or no? What do you guys think? Show me with your thumb. Are these two fractions equivalent? Show me with your thumb. Yes or no? Do they have the same amount shaded? Do they have the same amount shaded? I see two people shaking their head no. Okay, I see Brandon with his thumb down. You guys are correct. So which one has the bigger area shaded? Which one is the bigger fraction, 5/8 or 3/6? Go ahead and type in the chat box. Which one is the bigger fraction? So we can go ahead and say that these two fractions are not equivalent. So that's the equal sign. And to say that fractions are not equivalent, we draw a slash through the equal sign, which there's no key on your keyboard for that symbol, that things are not equal. So that's why we're typing in the chat box which one is bigger. All right, what'd you guys say? 5/8, fabulous. Oops. Okay, so remember as you work today, draw models to determine if your fractions are equivalent. So we can't just look at the numbers and figure it out that way. We have to draw a model to be able to figure out which fraction is bigger or smaller, or if they're equal. So that is it for the lesson today. So I'm going to press stop recording now. Stop share and